What's up, geometry students? Mr. Messer coming at you with the 3.4 homework. It's the last lesson we're doing in this kind of subunit, this mini unit, where we talked about how scale factors of sides do not equate to scale factors of areas. Probably the simplest example we could talk about is like, let's take a square that has a side length 1. Its area is one of these squares, a 1 by 1. And let's say I triple these sides. So like our lengths are going to triple. Our perimeter is going to triple. We're going to go from 4 to 12. But our area goes from 1 to 9. So we end up that like our area factor would be whatever scale factor ratio is squared. It's because we're not talking about like one-dimensional units. We're talking about two-dimensional units. Like how many of these squared boxes do we have? We have one. If I looked at it, we'd have 9 of these boxes. So, like, let's look at this 6 to 11. Well, I'd have to multiply by 11 6. Many of you are not comfortable with that, but you need to be comfortable. You could always divide the two to look at relative size. 1.833 times the size. Remember, dividing is an important way to talk about relative sizes of things. Like, how much bigger is this one compared to this? 1.833 times or 11.6 times the size. That's the scale factor. Well, the area factor is going to be this value squared. So you could take like 11 and square it, and you get 121. And you take 6 and square it, you get 36. Or you could have taken that 11.6 and square it and gotten 3.3611. That's the idea behind this lesson. We have the boxes that end up, multiplying, having squared units. Areas are in squared units. How many squares do we have versus lengths are just the length. So 5 to 8, you would say you'd be multiplying by 8/5, which is something that you guys need to be okay with. Like the scale factor is 8/5. The perimeter factor is going to be 8/5. Dividing the two will give you the relative size of each. So that's 1.6. You need 1.6 times the size of this 5 length to get to this 8th. And then if you want the area factor is going to be that squared. I guess it'd be like the scale factor for the area. So 8 squared is 64. 5 squared is 25. If you did the 1.6 and squared it, you'd get this value. $2.56. All right, then just understanding like one way you multiply, the other way you divide. If I were to go back with perimeters, I would divide by 1.6. If I had this area and want to go backwards, I'd have to divide by 2.56. You know what I mean? It's just or flip the ratio. And yeah, that's what we're doing. Got two similar triangles. Their areas and their ratios. So I'm going to put the number in the middle. Like this ratio is 9 to 16. Okay, so like the area would be like 16 ninths, which would be 1.777. So that's like the area factor. So what if I wanted the scale factor for like the lengths and the perimeters? Well, like think about how this is the scale factor squared. This is the scale factor squared. If you have the scale factor, which is something, if you have the area factor, which is the scale factored squared, how do we get the scale factor up here? We would take the square root and we realize, oh, 4/3, all the dimensions times 4/3 equates to all the areas times 16/9. Or watch this, 4/3 squared gives me that area 16/9. Okay, so if you have the scale factor, you can square it to get there. If you have the area factor, you can square root it to get there. It's kind of how things work with each other. Multiply, divide, square, square root, you know? This is an equilateral triangle. It's made up of 4 congruent equilateral triangles. What's the scale factor between one of the small triangles and the big triangle? All right, well, let's just take this top triangle on the top, and let's just say all of its lengths are 1, because it's an equilateral triangle. Well, then we just have a bunch of 1s everywhere, right? Well, that means we'd have this big triangle, which has lengths of 2. And it's made of these 4 smaller triangles with lengths of 1. So what's the scale factor between one of the small ones to one of the biggers? Well, the small one had lengths of 1. The big one has length of 2. The scale factor is 2. What is the ratio of the area? And like, let's look at the perimeter. The perimeter is 3. The perimeter is 6. So like the scale of the lengths is the same as the scale factor of the perimeter, but it's the area that's the difference. What's going to be the area factor? Well, scale factor 2 means the area factor is going to be 4. We don't have to do the calculations to check. We just know that it's the scale factor squared. The ratio would be 4:1 or 4:1. So let's pretend we didn't have the lengths here. If this area was 1, this area would be 4. The area of one of the larger triangles was 20. Determine the area of one of the smaller triangles. So if this area was 20, what would be the area of one of the smaller triangles? It's a great question. Well, we have the area factor is 4. So times 4 would go that way. Divided by 4 would go this way. So divided by 4, we'd get 5. 5, 10, 15, 20. Oh yeah, of course, it makes sense. Like that is a visualization of how this works out. Is how many triangles fit into the bigger triangle. And we kind of talked about that, like how many of our original shapes fit into our bigger shapes with our lesson. Cost of a piece of fabric. So the question is like, how would we pay for fabric? We have this fabric that's 9 by 21. And it costs $1.30. If we have this bigger piece of fabric that is 18 by 42, what would you expect to pay? Well, it's like, do you expect to double the price or more than that? Probably you're going to go by like square inches or the total amount of fabric that you have, not by like lengths. So we would want to know the area. So like this area versus this area, the dimensions would have a scale factor of 2, right? 21 to 42, 9 to 18. You divide the numbers to figure that out to show the relative size. this is twice as big as that. But its area would therefore be times 4. And you could also kind of double check that. 21 times 9 is 189. Just going to write this off to the side, 189. And then 42 times 18 will be 189 times 4. Watch this. 42 times 18 is 756. And I bet you that's the same as 189 times 4. Bam. Okay. Now, would you, if you owned a fabric shop, charge twice as much? Would you charge 262, or would you charge 4 times as much? I'm probably charging 4 times as much because we're like, it's that much more fabric which you had to produce. So that's what I'm going with. So 131 times 4 is some value. I could do this if I wanted to. 524. Why? Because it's like cost is based on total manufacturing. A triangle with an area of 10 is not a triangle. A triangle with an area of 10 has a base of 4. A similar triangle has an area of 90. What is the height of the larger triangle? Well, like this is one of those things where like we don't have to do all the minor calculations. You can see like the area factor is times 9. You go from 10 to 90. The area factor is times 9, which means like the length factor, the scale factor, the perimeter factor would have to be 3. If this was 4, this has to be 12. If we found this height here, we just multiply it by 3. Or we could take 90 and divide it by 12. Let me just show you all the different ways to get the answer. There's 7.5. I could have figured that out kind of going from an area factor to a scale factor and getting this 7.5. Or I could have said, if this is 4, this would have to be 5 halves or 2.5. 4 times 2.5 is 10. I could have divided the 2. Okay, so 4 times 2.5. I guess since I know my area factor, I need to know the scale factor. So that 2.5 times 3 would have got me that 7.5 as well. Just kind of like the order of what you're doing things in. So 7.5 is my answer. The circumference, which is the perimeter. It's a fancy word for perimeter of a circle. K is pi. The circumference of circle L is 4 pi. What is the ratio of their circumferences? Well, it's like 4 pi to pi is 4. If you have a perimeter of pi and a perimeter of 4 pi, you would be multiplying your perimeters by 4. Perimeters are just like the units going around would be the ratio of their radiuses. Well, like it would also be 4, which is just a length, but the ratios of their areas would be 16. This is me intuitively getting the answers. Let's see how we could have gotten them without having the understanding and just kind of working it out. 4 pi to pi 4. What is the ratio of the radiuses? Solve for the radiuses first. Okay, so circumference is 2 pi r. Let's go with the k. I had a perimeter of pi, and I can find the radius by dividing by 2 pi. Pi divided by 2 pi, a lot of you probably are confused by, but it's just a half. It's like r, 2 pi times a half gives you pi. So this r is a half. And then if we do it with the circle L, we have this 4 pi circumference, which means the radius is 2. So this radius is 2. Okay, 1/2 times 4. Yeah, it's a length. Scale factor will scale the same for perimeters and for any length inside your object, but the areas are going to be the scale factor squared. So taking this 4 and squaring it, if you want to go the other way, you would square root it. We would get area, which is pi r squared for k versus the area pi r squared for L. R is 1/2, which gives me 1/4 of pi. Here, a R of 2 would give me 4 pi. This times 16 gives me that. And if you didn't get that, it's fine. You don't have to do that. This is really just me checking. I would have just kind of understood the lesson and be able to get these answers first. Okay. All right. Good talk, team. See you out there. Peace.